Okay, good morning, afternoon, whatever, whenever you're seeing this. We are, whoops, we are going to start working on reviewing things that we learned first semester having to do with slope and slope-intercept equations. So today specifically is going to be all about slope. And so I found this awesome little, it's called a foldable because lo and behold, you get to fold it. And so it's got a blank side here that would be a piece that you like glue into a notebook or something. And so if you put that side down, that blank side is down, and then we're going to fold it kind of back and forth like an accordion type thing. They give you some lines as guides. Doesn't have to be perfect, but fold it and then fold it again, and then one more time, fold it again. All right, there we go. So that's not too bad. Oops, I cut off the S there. It's okay. I forgive myself. Okay, so we're going to talk. This thing has tons of information and examples in it. If you try to do it all at once in one step, you're going to get lost. So we're going to kind of focus on one little page at a time. And this this would be like the front page here. So slope of a line, this gives you some formulas, and it kind of tells you what we're going to do inside the foldable. So the first thing that you need to remember about slope is that it's a ratio. It's rise over run. And rise is the vertical change of a line on a graph, and the run is the horizontal change, left and right, of a line on a graph. So then when we write it as a ratio, it's just vertical change over horizontal change. And that is, well, that's the ratio. Whoops. And, okay, so the other thing that we need to remember is that there is a formula, and we didn't spend, honestly, as much time as I would like to have back then because we were kind of struggling and I just moved on. But we're going to come back and revisit this formula, and you really need to have a handle on this formula for algebra class for next year. So we're going to spend a little time with this one. But it's it's just the change in y over change in x, and we can represent change with subtraction. So if we're given two ordered pairs, we have an x and a y and then another x and a y, and we can put those x and y values into the formula and find our slope that way. We also spent quite a bit of time first semester talking about this equation, y equals mx plus b, and the letter that we use for slope is m, and so you see right there in the formula there's an m. So if you have an equation that looks like this, then whatever number is right there in front of the x, that number is your slope. And so it's really super simple to see a slope in an equation when it's written in that form. And then this is the one part of this foldable that we're going to kind of ignore because we never did this. This is called standard form of an equation. You will do this in algebra next year, but we're not going to do it in pre-algebra. We never did touch on that one. So we're just going to kind of skip anything that has that formula for now. Okay, so open it up, and then we can start looking at some specific examples here. And if I can zoom in a little bit, maybe. I thought I could zoom in, but evidently I don't know how to do that. Funny. All right, well, I know how to zoom in here. I can move the camera closer. There we go. All right. They give us an example here, and this is a negative slope. I know it's negative because the line is going down from left to right. We always read things on a graph from left to right, just like we read words in a book from left to right. So if I start over here at the left side of the graph, and as I go across, it's going down like that, that is a negative slope every time. And so all we have to do then, remember, it's rise over run, vertical change over horizontal change. So the vertical change of this line, just count from one dot to the next, is down 2, right 1, 2, 3. That's all I'm doing is counting. So down 1, 2, right 1, 2, 3. And we can do that all the way across the graph on this line. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And this line, that's what this line does. It goes down 2, right 3. That's what a negative 2 over 3 slope looks like. So let's look at the next one here. And we've got, for graph B here, we can go up 1, 2, 3, right 1, 2, 3. And then from this dot, we would go up 1, 2, 3, right 1, 2, 3. So since it's going up, it's a positive slope. It's 3 over 3. And then just like with any fraction, anytime you have a fraction or a ratio, you always want to simplify that. So 3 over 3 would simplify just to 1. This is a 1 slope. And if you look at that, it would go up 1, right 1, up 1, right 1, up 1, right 1. And it stays on the line as you do that up 1 and right 1. All right, then as we look at letter C, up 1, right 1, 2, 3, 4. And then up 1, right 1, 2, 3, 4. So the rise is 1 and the run is 4. That's a 1/4 slope, or up 1 over 4. All right, then slope D, or graph D. We're going to start here, and since we've got to go down as we move to the left, what does that mean? It's negative slope. So we're going to go down 1, 2, right 1, 2, 3, 4. So down 2, right 4. And we can do that again, down 1, 2, right 1, 2, 3, 4. So what does that simplify to? Negative 1/2. So our slope of this line is down 1, right 2. So down 1, right 1, 2. And look at that, I'm right back on the line. Down 1, right 1, 2. Okay? All right. So that is counting the slope given a graph. That's probably the easiest way, or one of the easiest ways that we have of finding slope, because it's just counting. Literally, it's just counting. On a table, it's a little less obvious, I think, but we still can do it. And I really like this example they give us here of what's going on. We're still going to talk about change in y, vertical change, over change in x, which is the horizontal change. It's the same thing as rise over run. We're just seeing the numbers instead of seeing a graph. And so as I look at the table, I notice that on this table, the y's go up by 2, right? And here the x's go up by 4. And so I can just set those as a ratio, the change in y over the change in x, and then simplify it. So the horizontal or the vertical change over the horizontal change, and then simplify it. But what if I've got a part of the graph that jumps a different number here? Well, now it goes up by 6, and here it goes up by 12. And if I put 6 over 12, look at that, it simplifies to the same thing. It still simplifies to the same slope. And that's good. We want it to be the same all the way down the line. Okay? So I would do the same thing here. Look at my y values, from -3 to -1. How much increase is that?
2.
It's a +2. And then from -2 to +1, how much increase is that?
1.
So that's a +3. And from -1 to +1, that's +2. From 1 to 4, that's +3. And then from 1 to 3, that's +2. And from 4 to 7, it's +3. So how do I set that up as a ratio then? It's just 2 over 3. And that one won't even simplify. It's just a change in y is 2, and the change in x is 3. So I can set that up as a ratio. All right, what if the table's laying on its side? Oh no, it's still going to work the same way. I'm still looking at change in y over change in x. So how do I get from 9 all the way down to -3? How big of a change is that?
-12.
That's -12. That's a -12 change. And then what about from -3 to -9? That's a minus 6. And then from negative 9 to negative 21, that's a minus 12 again, right? Okay, so what do I do to get from negative 4 to negative 2? That's plus 2. What about from negative 2 to negative 1? That's plus 1. And then from negative 1 to negative, or positive 1, that's plus 2. So I need to make sure that I choose the right numbers to put as my ratio, right? So for this first interval, it would be change in y is negative 12 over change in x is a positive 2. Okay, what does that simplify to? Negative 6. Okay, but what if I use this interval? This would be a negative 6 over a positive 1, and that is the same thing. It's still a negative 6. And here I've already got that negative 12 over 2 interval, so we know that's going to be the same thing. So I have the same slope all the way down as I go through this table. Okay? What about letter D down here? What do I do to get from negative 8 to negative 13? Minus 5. And from negative 13 to negative 14? Negative 1. And then from negative 14 to negative 16 is minus 2. Wow, this is a weird one. Okay, so what do I get from negative 3 to 7? That's a plus 10. And then what from 7 to 11? That's a plus 4. And then what about from 11 to 17? That's a plus 6. Okay? Let's see what we got here. So negative 5, or sorry, 10 over negative 5. What is that? Negative 2. I think they've made a mistake on this one. And then this one would be 4 over negative 1. Well, that's negative 4. And then this one would be 6 over negative 2, which is negative 3. So what does that mean if we have differing slopes like this? I don't think that they didn't make a mistake. They just gave us a different one to think about. So we've got 3 different slopes, which means this is not a straight line. This means we just found the rate of change between some different points. Okay, so the slope between these 2 points is different than the slope between these 2, and it's different than the slope between these 2. So this would be a graph that kind of makes a, like a zigzag or something. Okay. Do graphs sometimes do that? Yeah, it's okay if that happens. All right. Which, by the way, is the reason that you need to do this for all the points when you check a table, and not just say, like, we did 1 spot here, so we found the slope for everything. It might change like that when you've got a table. All right, so our other section here, given 2 points. If we have 2 ordered pairs, 1, 8 and 9, 12, we can put our x and y values into the formula. And so I've always got an x and a y and an x and a y in my ordered pairs. How do I know which one's x1 and y1 and which one's x2 and y2? X always comes first and y always comes second. And as long as I keep things in the right order, y2 comes from this one because they put the 12 first, right? So they put 12 first in the example. Then that means the x2 has to be the 9. I can't flip-flop those, okay? So they put y2 minus y1, that's 12 minus 8, over x2 minus x1, that's 9 minus 1. So 12 minus 8 is 4, 9 minus 1 is 8, and then they simplified it to be 1 over 2. Okay? So, x and y, right? So they're going to throw some negatives at us on the very first one here. So let's pay attention to that. So y2 minus y1 would be negative 4 minus 2. And then x2 minus x1 would be negative 3 minus negative 6. This is probably the harder, out of all the stuff that they have us do, I think this part of finding slope is the most difficult of what we did. But once you're used to it, it gets easier. So negative 4 minus 2 is negative 6, and then negative 3, and when you subtract a negative, what is that? It's really like adding, right? So negative 3 plus 6 would be positive 3. All right? So negative 6 over positive 3 is negative 2. So the slope of this line is negative 2. All right. So x1, y1, and x2, y2. So negative 2 minus negative 3 over negative 1 minus 3. So what is negative 2 minus negative 3? Or negative 2 plus 3. We'll work on that right there. It's actually positive 1. Hey guys. It's actually positive 1 because negative 2 plus 3 would be positive 1. And then negative 1 minus 3 is negative 4. So it's just negative 1 over 4 for the slope. All right, so one more time, x1, y1, x2, y2. So y2 is 4 minus negative 1 over 5 minus negative 2. So that comes out to be 4 plus 1 over 5 plus 2. So the slope is just 5 over 7. Okay? And then this last one, given an equation written in slope-intercept form, and that's what this equation is, y equals mx plus b. M is the slope, and b is the y-intercept of the line. We'll talk more about that later on as we get further into our review. So not today, but later on in the week. So m, that's the letter that stands for slope. So whatever number is in that spot in my equation is my slope. All right, so they give you an example here, y equals negative 8x minus 7. Well, that number is where the letter m is in the equation, so the m is negative 8. All right, look at b. So what number is in the spot where my m goes? 4 over 9. That's where the m goes. It's in front of the x. So 4 over 9 is my slope. What about c? Negative 1. There's a number there, even though I don't see it. The number that's in front of that x is 1. How many x's are there? There's 1x. So there's a 1 there. So my slope is negative 1. Okay? And then the last one, y equals negative 1/5 x. So what letter, or what number is where the letter m would go? Negative 1/5. So my slope is negative 1/5, that 1 over 5. That line would go down 1, right 5. Okay, we're skipping this part because we did not do standard form equations. And so then if we go back here and open up the other side of the foldable that we haven't looked at yet, we've got 2 other pages. First, just a couple of examples. Positive slope, this is what a positive slope looks like. It goes up from left to right. And it can be really steep and it can be really shallow, but it always goes up as you read it from left to right. Negative always goes down from left to right. And it can be really steep or it can be really shallow, but it's always going to go down. A zero slope is a horizontal line. Think about riding your bike on a sidewalk that's perfectly flat. It's got zero slope. It's a horizontal line, right? That would be easy to ride your bike on it. Versus a they call this a no slope. We also called this undefined. Go ahead and write the word undefined. This is called, some books, some people call it a no slope. I don't prefer, I think no slope is too close to zero slope. I usually don't call it a no slope. I usually call it undefined. And it's a vertical line. Try riding your bike on that one. That'd be hard to do. All right. Here's a couple more examples for you to work through. Since we did examples of all of these as we work through the foldable, I'm going to let you do those on your own, except, of course, this bottom one because we didn't do that. So that's it. That's a review foldable for you to fill out and keep in your notes, because we're going to be doing a lot more with slope and linear equations over the next few days in our review before the end of the year. All right. Thanks, guys.